Hello, and welcome to Worksheet 7, where we're talking about trees and some other things. Basically, trees are a very important data structure. You've probably seen them in other classes if you've taken it like 621A before, but in 621B, we're going to go very deep into trees. We're going to use them a lot. They're recursively defined data structures, so we're going to do a lot of recursion. And yeah, you'll get very used to doing a lot of the things on this worksheet. They're kind of in a lot of ways the like bread and butter of a lot of algorithm design and computer science data structure analysis. So we'll start off right here doing these algorithms of DFS and BFS. These are some of the most famous algorithms in computer science. They're some of the most fundamental ones. And they're a great thing that you will eventually get so good at, you can just do it in your head. But I will show you how to do these things. Okay, so basically what we want to do is we want to traverse this tree in 4 different ways. We want to traverse it using a pre-order search, post-order search, in-order search, and level order search. If you're not familiar with these terms, you may have heard of DFS or depth first search. All 3 of these are types of DFS, and BFS, which is a breadth first search. This last one is also just called a BFS search very frequently. So DFS, depth first, we want to go down the tree first and explore nodes deepest back up, and BFS, we want to go wide and we want to explore layer by layer, basically. These terms you'll hear a lot, so I just want to clear up what they are. So again, DFS is a general term for all 3 of these traversals, but if you ever hear someone say run a DFS on this tree without telling you pre-order, post-order, in-order, they mean pre-order. This is generally what BFS means, or DFS means, sorry. But anyways, there are variants of it, and we'll talk about how to do each of them. Okay, so basically all of these, we're going to focus on the DFS ones first. So these 3 traversals are all basically going to start at the top of our tree, node 6, and we're going to check the other nodes in some order. And fundamentally, there are 3 different orders here. So in a pre-order, we are going to visit our node, then we're going to check the left node, then we're going to check the right node. In a post-order, we are going to check the left node, then check the right node, then we are going to visit. And in an in-order, we are going to check the left node, we're going to visit, and we're going to check the right node. That's basically it is. It's the same thing, but you're just doing the steps in different orders, and that will give us different results, right? So some things to clear up. What do we mean by left and right? By left and right, we're always talking about binary trees. So we just mean the left child or the right child. Keep in mind this process, if you had a tree that was like a ternary tree, maybe you had 3 children per node, you might have to adapt this process a little bit. It might look different. So these, as they apply here, only apply to binary trees, but there are more general search algorithms we'll talk about later in the class. Next thing is visit. What does it mean to visit a node? Visit just means to do some operation on a node. So this is a very simple example, right? It's just a binary search tree full of numbers. You can imagine that visiting might just be printing out each number. Or you could imagine that if you have a binary search tree, but it's full of like person objects, each one might, increment their age by 1. It just means you're doing something. You're doing the thing that you want to do. In a lot of pseudocode, you'll see like visit a node, and it just means you're doing what you want to do. But you can imagine for these purposes, we're just printing. So when it says, what is the pre-order traversal of a tree? This would be the same thing as we just asked, hey, print out every node in a pre-order. What's it going to be? Okay, all that introduction aside, let's do the actual traversals. So we're going to start at 6, and I'm just going to put a little X next to a node once we've visited it. So with a pre-order traversal, first thing we want to do is visit. So if we start at node 6, we're going to visit it, right? So that is going to be the first thing. Then we're going to go left. So left is this way, of course. So then we're going to go to 4, and then we're going to start this process again recursively, right? So far, we've visited 6 and we've gone left. We haven't gone right yet because we're doing the recursive step first, right? After we're done on 4, we'll come back up to 6. So now on 4, we're going to visit, and we're going to go left, right? Remember, we're going to put this right traversal on hold because going left necessitates we go recursively to the next layer. We go to the 2 node. First thing we do is we visit, and then we are going to go to the 1 node. So the 1 node, we're going to visit it, and now we're going to visit we're going to visit one's left child. Well, one's left child is null. It doesn't have a left child, so we're done, right? This is basically a base case we've reached now. So now that we have visited 1, we've gone and seen all of its left children. We're going to go and we're going to see its right child. Well, 1 has no right children, so that's also done, right? So in other words, we're now completely done with our scan in terms of 1, right? So I hope that makes sense. We started at 6, we visited, we went left. We went to 4, we visited, we went left. We went to 2, we visited, we went left. We went to 1, we went left. We can't go left, so we go right. We can't go right, so now we're going to go back up to the 2 node, right? So remember, where we last saw the 2 node, we were going to visit 2's left child. When we're done visiting 2's left child, which was the whole recursive process, now we're going to visit the right child. 2 has no right child. So we're going to go back up to the 4 node. Remember the 4 node, we haven't visited the right child yet, so we're going to visit the right child, which is 5. And now we're going to run this recursive process again. We're going to visit 5. We're going to go left. It has nothing on the left. We're going to go right. It has nothing on the right. So we go back up to 4. We visit the left and right child of 4. So we're done with that. Now we go all the way back up to 6. And now we're done visiting 6's left child because we just returned from 4. So now we can go right on the 6 node. We're going to go to 9. We'll visit it. We're going to go left. That will bring us to the 8 node. We're going to visit it. We're going to go left. That'll bring us 7 node. We're going to visit it. We're going to go left. There's no left. We're going to go right. There's no right. Go back up to 8. Go right. There's no right. Go back up to 9. Go right. There's no right. Go back up to 6. Now we visited both left and right. And now that we've run visit left and right on 6 on a root node, we know that we're done. That was a very verbose process, but that's basically how you do this entire thing. So at every node, you basically apply this process. And if there is something to the left, you just apply it to the left node, right? So it's a recursive process all the way down till you get to the base case. So remember, this is also called a DFS search. And notice what happened. If you look at the order we visited things in, the chain of nodes we visited was like this. So notice that before we ever went to 9, we visited everything below 4. So we went depth first, right? Even though 9 is only 1 link away from 6, our root node, we went all the way down to 1 before we visited it. Okay, that's the kind of technical way to do it. Here is a quick trick if you want to do it in your head really easily or in an exam. Basically, something you can do is if you draw like a little line to the left of every node, and then basically you just draw a line the counterclockwise around the node, you'll get the preorder. So what I mean is you see how I drew a line to the left on every one of these. If I just draw something like this, just kind of hug the interior of the tree. This is it, right? 6, 4, 2, 1, 5, 9, 8, 7, right? If you see the way I drew the line, it will actually go in the preorder this way. So this is another way to do it. One way you can think about this too is that in preorder, we visit before we go to the to the right or to the left. So basically by drawing something on the left every time, if we do all that, it will come and chain around. Yeah, so this is a quick trick. If you want to do it in your head really easily, I do recommend you learn the kind of real way to do it, but it's good to know. Okay, so we're going to speed up on the other 2 ones because the process is going to be pretty similar. So post order, we're going to do the same thing, except we're going to flip our order around. So we're going to visit left, or we're going to go left, then we're going to go right, then we're going to visit. So we start at 6 again, but we do not visit 6, right? First thing we do is we go left. So 6 is not going to get an X on it at first. Then we're going to go to 4. Then we're going to go to its left child. Then we're going to go 2. We're going to go to its left child. Then we're going to go 1. Go to its left child. 1 doesn't have left child. Then we go to its right child. 1 doesn't have a right child. And now that we've visited both the left and the right child of 1, we can finally visit 1 itself, right? So this is truly like a DFS search, right? We visited the deepest node first. And that's because we only visit the node once we've visited the left and the right children, which means the first node we are going to visit is one that doesn't have left or right children, right? Okay, so after we've done that, we're going to return up to the 2 node, which is where we came from. So we've now visited the left of 2. So now we're going to visit the right of 2. There is no right of 2. So we are going to now visit 2 itself. Go back up to the next level. So now we're at 4. Now that we visited 2, we've visited the left of 4. So now we're going to go to the right of 4. So we're going to go to 5. Visit 5's left and right. It doesn't have any. So then we're going to visit 5 itself. And then we're going to go back up to 4. We've now visited 4's left, which is 2, 4's right, which is 5. So we are going to visit 4 itself. Go back up to 6. So now we are done finishing with traversing 6's left. So we're going to traverse 6's right. And we're basically going to do the same thing. We're going to go to 9. We're going to go left. We're going to go to 8. We're going to go left. We're going to go to 7. Go left. Can't go left. Go right. Can't go right. So then we're going to visit. Go back up to 8. We've gone left. So now we're going to go right. Can't go right. Visit. Go back up to 9. We've gone left. Can't go right. Visit. And now we're going to go back up to 6. We've gone left, we've gone right. So now we can finally visit 6 like that. So we get this traversal order. The quick way to do it, also akin to pre-order, because this one might be a little hard to do in your head, is we're going to do the same thing we did before, where we drew a line to the left, except now we're going to draw a line to the right of every node. And we're going to draw the same thing, line around here, hugging the inside of the tree. And you see we get 1, 2, 5, 4, 7, 8, 9, 6 in that order. This is a quick way to do post order. If I'm trying to do it in my head, this is how I will normally do it. But again, you should probably learn the real way first. Yeah, so that's how a post order works. Things to note about post order is the root of the tree is going to be the last node visited, right? Because it's the opposite of what we did before. Before in the pre-order, the root was the first node visited because the first thing we do is visit a node. Now the last thing we do is visit a node, and we can only visit it once its children are done being visited. So we're going to do that. Another kind of theoretical thing to realize about post order is, again, we only visit a node once both of its children are visited. Notice that we visited 1, then 2, then 5, then 4. The reason 4 only got visited after was because we had to visit 2 first, and to visit 2 we had to visit 1, and we had to visit 5 first. So you only get visited after your children are. Therefore, kind of one of the deepest nodes is always going to get visited first. Okay, in order traversal of the tree is going to be the same thing, except we're going left, visit, and right. So now to do this quickly, we're going to start at 6. We're going to go left, start at 4, go left, 2, go left, 1, go left, can't go left. So then we're going to visit, then we're going to go right, can't go right. We're going to go back up to 2. We just went left, now we're going to visit, and then go right, can't go right. Go back up to 4. We just went left, so now we're going to visit. Then we're going to go right. We're going to 5. We're going to go left first, can't go left, visit. Then go right, can't go right. Then we're going to go all the way back up to 6. Now that we can go back up to 4 and visit the right, we're going to go to 6. We just visited the left. Now we're going to visit the middle. So we're going to do that. Then we're going to go right. We're going to go 9, go left, go left, go left, all the way down till we get to 7. Try to go left, can't go left, visit 7. Try to go right, can't go right, go up to 8, visit 8. Can't go right, go up to 9, visit 9, can't go right. So we're done, right? And then we go back to the 6, but we're already done visiting 6. Notice that this is just in order, 1, 2, 4, 5, 6, 7, 8. I don't know why there's no 3 in this tree, but notice that an in-order search is also literally just scanning left to right, right? If you just look at these nodes left to right, like if you just ran a kind of, you flattened them down into a single line into 2 dimensions, like a number plot, and just read it left to right, that would be an in-order search. That's why it's called an in-order search. And in the case you have a sorted binary tree, which binary trees are inherently sorted, you're always just going to get a sorted order out. Keeping in theme with the other previous examples, before we drew a line to the left of nodes, then we drew a line to the right of nodes. If we want to do an in-order search, you can draw a line at the bottom of the node and do like that. And that will give you the order 1, 2, 4, 5, 6, 7, 8, 9. And that is in order. Another thing to note about in order is that in order only works on binary search trees. We have notions of pre-order and post-order on more general trees that have more nodes or just more general graphs, which we'll talk about later in this class. But notice that inherently an in-order traversal must only happen on binary tree because you have to put the visit in the middle of the left and the right. Okay, so those are the big ones for DFS. Now let's do BFS, or level order as it is sometimes called. BFS should be pretty easy to just do on paper, hopefully. Basically, all you do is you go left to right, level by level. So first it's going to be 6, because we're going to go level by level. So first we're going to do 6, then we're going to do 4 and 9. Then we're going to do 2 and 5 and 8. And then we're going to do 1 and 7. So again, left to right, layer by layer. And if you have a nice diagram like this, where everything is like all evenly spaced and everything, hopefully that shouldn't be too bad. Okay, that's how you do these traversals. I hope this helps, and I'll see you in the next video.